Nočnica Fee. She's a senior developer advocate at New Relic, and we will have a recording of Nočnica on the topic open source infrastructure as a code for everyone.
Hello, people of the DevOps world. This is Infrastructure as Code for Everyone, meet Opta. I am so happy to be here talking to you about this. This is a super cool topic. Infrastructure as Code is obviously a really essential piece of a modern DevOps toolkit. So, let's get right into it. Let's get the scene back. So, who am I to be telling you these things? My name is Nočnica. I was a developer for 9 years, working in cloud spaces and containerized workloads. You can find me every place at Serverless Mom. Obviously, I worked with Serverless for some time. And these days, I talk quite a bit about containerized workloads. I also run the Containers PDX Portland Containerized Workload Meetup. What else? You can find my writing everywhere and hopefully a little bit of my code. Okay, so what is infrastructure as code, right? I had an interesting conversation a little while ago where infrastructure as code was kind of referred to as like this carnival trick that was for public clouds, right? If they can automate everything, then it's this really cool automation feature to say, well, I can just give you some little file and you can go ahead and deploy everything. But infrastructure as code is not a cloud specific, it's not an AWS specific or Azure specific or anything like that sort of limited use tool. It's a very general idea about the storing and sharing of configuration. So, right, infrastructure as code, and I'll obey the rule of reading all the text that I have on the screen, right? It's provisioning and configuration defined as code or templates, right? It's tracked as part of a repository, and it's basically the opposite of this. Oh, I did see a comment the other day that said, oh, it's not infrastructure as code because you're using a YAML template. I don't know what to say about that, right? YAML is I mean, like, it's not executable code, I guess, but I'm not going to say infrastructure is template, infrastructure is code, but infra as code refers to this idea, right? So the opposite of what? The opposite of going in, hitting configure, and then configuring something within a dashboard somewhere for your public cloud provider, or going in and accessing a server remotely, entering in single commands to say, okay, this is how it's configured. And a kind of in-between state, which is a very common state, is, hey, I have a bash script to go ahead and provision this, and you need to pop in and out these variables, but then where is that bash script? Where is it kept? Where is it tracked? Those are maybe broken pieces or pieces that don't follow the infrastructure as code model. So why is this important? Infrastructure as code is good for you, right? So the idea here is, just like eat your vegetables. So let's talk about it. So infrastructure as code gets you what? It gets you some repeatability, right? Setting up a second copy of any surface, host, or architecture is easier when all the steps are codified. So what you find when you don't use an infra as code tool, and I think we've all been there, is this one config thing you have to go ahead and just go set. Right? Or, hey, this one memory piece you have to go ahead and just do. Or, hey, this auth component, you have to go and grab these keys, and that's something you just have to get from the person who knows in Slack or something. So that has lower repeatability than using an infra as code tool. So there are a few ways that infrastructure as code improves resilience, including a better ability to roll back. But the one I think is most critical is that it increases your bust factor. So actual technical resilience is great, but your resilience to changes on your team, to people being out, to people not being currently on call or available, that's the part that is really enhanced. Because if you're really sticking to this model, then all of the steps that total expert did to stand this up should have been codified quite literally, and enable for somebody to repeat. So let's talk about this communication piece, right? Sharing templates makes clear what config needs to be done to run the service. It's even possible to use shared templates from outside the org, right? So communication is one that I really can't stress enough. The ability to see a commit history about how our infra has changed is incredibly helpful. And for training new people, right, communicating between teams, this is all really critical stuff. A possible 4 here is improved security and auditing, but I actually feel like it's covered by this, right? It's the communication and collaboration piece that's really critical. And back when DevOps was not a role, but just a design ideal, I think that infrastructure as code was a very key piece of that DevOps story to say, hey, you may not work on this all the time, but it is recorded here what we have to do to create one of these services, and you can go ahead and examine it and learn a little bit about how your code is actually running. Take a sip of green tea, let's get back to it. Okay, so we're going to talk for a minute about Terraform, which is one of the most popular tools for this, is beloved by the community, and rightly so. Like, Terraform's a very common and frequent way to do this infrastructure as code process. It's the number one tool, but let's talk about some of the areas that it has some not even vulnerabilities, but some of the things that are difficult to just say, oh, well, we'll just use Terraform. You're probably not going to be able to go in on Monday and say, hey, I want everybody to start using Terraform for our stuff, and then by Wednesday, you're switched over and you're using that tool. Terraform is a tool for experts, and to use it well, you have to be prepared to handle the following stuff. Right? Because control and collaboration can be a delicate balance, right? When we want to say, hey, I want to give a lot of people access, for example, a lot of people access to our Terraform templates, but then you want people to be able to collaborate on this stuff, but then trying to balance that with the right level of control can be somewhat delicate. So the first thing, and it's significant, is state drift. So Terraform uses state files to record the current infrastructure state, but the reality of the infrastructure can deviate from that state file. So one of the situations that this happens a lot in is Terraform apply failed, right? So we're halfway through some kind of application. We don't have a good track of where things are, and so we very often find ourselves really kind of wishing, oh, let's just spin down this virtual machine and just start from scratch. And so you get these resource already exists errors. It can be frustrating. Another one, right, is manual changes to the resource. Now, this is none of this stuff that we're talking about is like bugs or like, oh, we need to address this. This is like design limitations of the tool, right? By design, if someone has made a one-off change to the resource, let's say you woke up, there was some crisis, you went ahead and SSH'd into that service and you went and updated its settings, right? That is going to be a mismatch between the Terraform state and what is actually out there. It becomes really difficult at that point to bring Terraform in sync, and the time that you spend on it, the cycles that you spend on it, it's pretty easy to feel like that's wasted time, right? If we were just running our config de facto, right, then okay, we made a midnight change, and in the morning, we'll just keep doing what we've been doing. Now, Terraform saves you tons of time. So it's not that you're going to be like, oh, this was just, we should never use this tool. But it is sort of a moment when it's like, oh, there's costs associated with doing this, when we have to bring state up into sync. So let's talk about hard dependencies, right? Terraform makes it easy to reference the outputs of resources or other modules, but it only works if all those resources are part of a single state. And that can lead to some issues. So I'm not going to dive super deep on the hard dependencies, but I think it's, reasonable to say, obviously we want to be able to include module outputs, but if they've started to drift, again, we start to have a little trouble. And then the last thing is this difficulty with templatization, right? So can you make a clone of what you have by reusing, your Terraform template? Yeah, of course you can. That's very, very easy. But of course, at the basic level, you would never want to make an exact copy, do you? Right? At least you want to make something that's running in a different environment, if not with different authentication keys, with different routing, with different settings, right? And so teams usually want to spin up multiple environments by just changing a few Terraform variables, right? That's the dream, right? It becomes tricky when you have sort of larger configuration states, right? If you have hard dependencies, you can't share variables across Terraform states, and each module within a given state can have a few variables based on which environment it's deployed into. You want to use different instance types in prod and QA, and eventually when you try managing all this inside of a single template, it becomes this big massive spaghetti, and you start to have a template that totally makes sense for the experts who set it up, but is not, that communication goal can break down a little bit. We were starting to say, okay, sure, anyone can go look at this thing, it's in the repository, but when you do, it's a maze, right? And so it's really something that experts are going to understand well, that sharing between experts is going to do well, but that, again, that kind of DevOps goal where your very smart front-end developer who does a ton of stuff about their field tries to like dip in and just see like, okay, wait, we have this, we rely on this microservice, how is it configured? They're going to feel like, oh, this is like impossible to figure out. So, infrastructure as code tools, there's a number out there, and let's name some top ones. You have Terraform, you have Pulumi, and you have the AWS CloudFormation and the AWS CDK, right? Obviously, AWS CloudFormation and CDK are specific cloud. I wouldn't get too hung up on that, right? Probably if you're working with an Infra-as-code tool to go pretty deep on a particular cloud, you know you're going to be there for a little while, so rare is the person who goes really deep on the AWS cloud deployment kit or something and then says, oh, well, I have to switch clouds next Thursday, right? That's not a very, very common one. So I'll turn off my video for a sec so we can see all these points, right? We want to have this declarative structure that has support for low-level configuration, and there's a really good community out there with all of these tools. There is definitely a steep learning curve, right? And the encoded wisdom is a little tough, right? Because you're very often working from scratch to create your template. It's, using a complete template from someplace else is probably not going to give you the kind of security and assurity that you expect. So it's not that these tools are bad or have design flaws. It's just that the design challenge that they solve, giving you a great deal of low-level configuration, means that managing and creating them is complicated. So we shouldn't be getting rid of Terraform. It's a great tool that works on multiple clouds, but when you're facing the issue of overly complex templates that most engineers can't share or maintain easily, abstraction is something that you want to consider, right? All of us perform our work every day through multiple layers of abstraction to say, hey, I need to be able to work on this from a high level, and I don't want to disappear into the exact way that these things are configured. Anybody who's stored a variable in JavaScript can tell you that it doesn't make life easy.
Hi, we are Eficode, and we organize the DEVOPS Conference. Delivering the benefits of DevOps through cloud gives the scalability, availability, and cost-effectiveness we all want. We would love to speak to you to learn how we could help you to do DevOps better in the cloud. You can find us at Eficode.com. The links are in the description. And have a great time with the DevOps Conference talks.
So let's talk about Opta. So Opta is a free open source tool that is for infrastructure experts to deliver their expertise to non-infrastructure experts, right? It allows you to eliminate a great deal of low-level configuration by allowing you to use modules that other experts have written. It gives you a library of modules that you can connect together to build your ideal infrastructure stack. And Opta is not a rejection of Terraform because Opta uses Terraform under the hood. So you're not locked in. You can always write custom Terraform or even take the Opta-generated Terraform and run that through Terraform. Now, again, we're not trying to replace Terraform, nor are we trying to replace the AWS CDK or Pulumi, right? There are other tools that have their own strengths and weaknesses. Opta is designed for folks who are not infrastructure DevOps experts, but still want to build amazing, scalable infrastructure. So here's a bunch of features, but let's just go ahead and take a look at it. Let's look at an install process. I'm actually having a little trouble with my whole environment. This is a machine I got set up yesterday, so I'm going to let Ankur, the head of the Opta team, take it away and do a quick demo here.
So the first step is creating an opta.yml file, which describes the environment we want to create. And this would help us set up the architecture that we were discussing in the slides before. So I'm specifying my AWS account ID and region here. Then I'm connecting together a few of our base modules. So as you can see, I'm setting up a domain name here. I'm setting up a Kubernetes cluster with maximum nodes 8. And I'm adding some base Kubernetes resources. So there are a bunch of configuration options you can access here to tweak the kind of infra you want, which are all detailed in our documentation that I will provide you a link to towards the end. Once your file is created, you just run opta apply. As you can see, Opta is built over Terraform, but instead of you having to configure every single thing by hand, Opta provides you an industry standard setup with all the best practices built in. Looks like Opta is now finished, so we can go to our AWS console and see what all resources it created. So if I take you to AWS, you can see that it created a Kubernetes cluster for us. The cluster has an auto-scaling number of nodes. So it's 4 currently, it can go up to 8 as we specified. And you can see it installed a bunch of stuff for us. There's an ingress here, there's a metric server, there is a service mesh as well. Additionally, we can see that our RDS database is created and our Redis Elastic Cache is also there. So once all this is set up, the next step is deploying our application. So my Rails application is available here, and it has this Docker file that I've already built. So this is my Docker file. I've already built this, so I'm just going to move on to the next step, which is creating another opta.yml. This one would describe the service. So here is the opta.yml that I created for the service. And you can see here that we are referring to the environment that we created in the previous step. Then we are specifying a bunch of configuration, like the port that I want to use, the health check path, the URI that I wanted to be exposed on, a bunch of environment variables, secrets, resources. Again, there's a bunch of configuration available here. All of that is detailed in our docs. And then lastly, I'm setting up a Postgres database and an Redis cache, and I'm linking them with my containers. What linking does is it would create these resources and pass the credentials to your container as environment variables. So once everything is set up, we just need to run opta deploy, and we provide our image here, which I have already built. And so my Docker image is called Rails with the tag v8. So as before, Opta is going to connect to your AWS account. It's going to connect to your Kubernetes cluster. It's going to push this Docker image to ECR, and then it's going to begin the deployment. So it looks like the deployment is in process right now, and you can see live logs being streamed from your Kubernetes cluster. Looks like our application has now started. And we are now done. So if you remember, we set the domain name for this application as rails.parent.domain, and our parent domain is demo.runx.dev. Let's go back to our browser, and I'm going to open rails.demo.runx.dev. So here we have our application running on AWS in Kubernetes. And just to make sure we have the database and everything set up, I can go here and try to create a new shark. And looks like it works. Cool. And then lastly, I just want to show you some other things that Opta provides. I can run Opta logs here, which will start streaming live logs from my containers. So here are the logs. I can run Opta shell, which would have me SSH into a running container. And there I can explore the environment. I can run one of tasks like db migrate. So here I'm inside the container. So that's all. This was a really quick overview of Opta, but there's a lot more Opta can do. We have stuff like secrets management, auto scaling, CI/CD, observability integrations. All of that stuff is there.
Okay, Ankur, thank you so much for stepping in at the last minute to record that quick demo of the install process. Like you said, there's a lot more to show, so do go ahead and join us. You can take a look at the free and open source tool on GitHub. Join us at our Slack at slack.opta.dev, or take a look at the docs. Folks, that's been my time. I appreciate you so much. Thank you so much for joining us. And look me up on Twitter at serverless_mom. Have a great day.